This session is going to be a continuation of my previous presentation. No slides, just a rather big demo about the typical CIDR workflow. I know that it is not really easy to figure out how you're supposed to program in this highly incremental and interactive manner that I described, unless you've seen it. We constantly promised our users that we are going to record a series of video lessons, and we never did it. Maybe because we are lazy, maybe because we are busy. But I know for a fact that we made some promises and didn't really honor them. So I'm going to start really from scratch, from establishing a connection to a project, doing the really super basic operations that you would do every day, and then I'm going to switch to some fancier, more advanced stuff. Okay, so we need some project. I happen to have some project called CIDR demo. Nothing really fancy here, but we need some project so we can initiate the CIDR jack-in functionality. Basically, the jack-in command starts an nrepo server with the context of the current project and connects CIDR to it. As I told you in the previous presentation, CIDR is the client component of a client-server application. So we are now connected. And I see something interesting. The screen resolution was such that the repo couldn't be seen, but basically when you're connected, you get to see an inspirational message, and you are dropped into a repo buffer where you can start evaluating code. By the way, the repo buffers were very confusing for newcomers, so recently we've added a ton of informational text on how you can get started with the buffer, which are some of the things that you can do first. We've added a link to the troubleshooting manual because so many people end up in trouble. So first we are going to go over the really basic stuff. The most basic thing that you can do in a Clojure repo, surprise, surprise, is evaluating some Clojure code. You probably didn't see this, but in the repo, as in the source buffers, you are getting things like LDoc. LDoc is the Emacs terminology for showing the prototype of a function, the signature. And when you type, you can also see how the proper argument is highlighted in the bottom, so it is pretty cool. If you're curious about the usage of some function, you can simply use a command that is invoked with the combination Ctrl-C, Ctrl-D, which is going to show the documentation of the function for you. Pretty handy. All the available signatures. A mention where the function is defined, and some related functions. From here, you can go to the source of the function in question. This one is defined in core CLJ in Clojure itself. Pretty handy, and you can easily go back to the documentation buffer by pressing meta, comma. This is super common thing. So actually from the repo buffer itself, if you're positioned over the name of some symbol, you can press meta dot, and this is going to take you to the source, and with meta comma, you go back. I think that this is basic, and probably all the Clojure developers are using it, but still, I felt it's worth mentioning. So when you're at the doc buffer, you see that there are also some related functions. Those actually are not dynamically derived. There is one big source file, an hidden file, where there is a mapping between functions and their related functions, macros, and so on. So if somebody wants to augment this, this has to be edited in the middleware. It's not super convenient. Maybe we are going to make it extensible via Emacs list, purely via Emacs list, but we were thinking whether some people would actually want to add something custom to the section or not. So basic stuff. You get code completion here. So if you type map, you start seeing all the functions that are currently loaded in this namespace and have a name that starts with map. You see their namespaces, their types. F stands for function. If something was a macro, like def macro, you see M. If something is a variable, you see a V. And if something is a special symbol, you see an S. So this is convenient. So we can do something like map, inc, basic stuff. It works. So this is the repo for you. Usually you wouldn't go writing anything fancy in the repo. It is much more convenient to be working with source buffers. So there is a really handy shortcut for you to switch quickly between a repo and a source buffer. It is Control-C, Control-Z. The source buffer I was saying is not very useful, so I'm going to leverage another project of mine. Another project of mine called Projectile, which allows us to quickly navigate within the files of a project. And here we have one core namespace, which is going to serve as the basis of our explorations. Right now, nothing seems to be working here. For instance, I go here. I don't get any LDoc. I try to evaluate this. I get a compilation error. And the form that I try to evaluate is underlined with a red line. Why is this? Because for you to be able to manipulate this code, you first have to load the code. This is done with the command Control-C, Control-K. By the way, there are many commands, and it is really hard to remember all of them. So for the evaluation commands in particular, as there are so many of them, there is a separate menu. The most important commands are evaluating the entire namespace, Control-C, Control-K, evaluating the current top-level form, Control Meta X, which is also bound to Control-C, Control-C, and evaluating the current expression, the expression surrounding your cursor point, plus evaluating the expression preceding your cursor point. You'll see those in action in a bit. So now everything in this buffer is evaluated. You can't really see it because of my rather ugly theme, but here there are little blue markers in the fringe indicating that all those forms are evaluated. If you change any of the forms, for instance this one, the fringe is going to disappear. This gives you a really good idea which parts of the codes have been touched recently and which are in sync with what has been loaded in the repo so far. So let's start doing something useful. We want to evaluate the function greeting with some arguments. So we start typing greeting and nothing happens. Why is this happening? Because we are not in the namespace and we have to refer to the function by its complete name. Now we get completion, greeting, oops. We get the LDoc, we try with Ivan, it works. We try with Bujidar, it also works. Am I blocking the view or something? Yeah. And as I showed you quickly in the other presentation, we can go to the source of the function, quickly change something. Maybe we want Alex to be the master of the universe. And this is a good place to use different evaluation commands. So I can go to the end of this function definition and use here evaluate the expression preceding point. But this is inefficient. What would a person normally do at this point is press Control C, and evaluate the current top-level form. And the current top-level form is this defun. To get an idea what is the difference between evaluating the current top-level form versus evaluating the format point. So with the command Control C, Control C, Control V, V, you are getting the result to become, okay, this is a little bit moronic. It shouldn't be working like this. Maybe I did something dumb. Okay, I'll have to see what exactly I wrote because this wasn't supposed to work like this. This is actually evaluating the form right beneath the cursor, and it was supposed to be evaluating the surrounding form. But yeah. Okay, so work in progress. A disclaimer.
New CIDR release called means?
After London, the next CIDR release is going to be codenamed London. We don't have a roadmap. We don't have any plan for the future, but we know it's going to be awesome. Okay, so we played a little bit with one function. I know. Oh, sorry about this. We are now going to check that for Alex we are getting different results. Yeah, Alex is now the master of the universe. Nothing super interesting or important here. What is somewhat interesting, as I showed you before, is that you don't really need to go to the REPL buffers to quickly check the result of some function. Every time you evaluate a function, you are going to see its result inline, displayed inline in the source buffer. The result is going to disappear when you move the cursor. And you're going also to see it in the mini buffer. Traditionally, we have always been displaying results in the mini buffer, and displaying them inline was something we've added about 1 year ago. Like everything in CIDR and Emacs, this is super configurable. You can elect to see the evaluation results only here, or at both places. Pretty much every aspect of the work of CIDR is configurable. For instance, if we want to check the documentation for string, for the string method, by default we are prompted, do we really want to see the documentation for a string? That there is a reason why this is the default. I won't go into details, but there is also an option to stop prompting for this and just show display to you automatically the documentation for the symbol at point. So this is pretty convenient. Going forward, what else can you do apart from evaluating forms? From time to time, some things simply don't work, so we've got some debugging functionality, and from time to time you want to be doing some more advanced documentation searches. There is a functionality that we call apropos. It looks like this. The idea for the apropos functionality is that you know that there was a function in Clojure that was doing what you need to do, but you don't remember the exact name. You remember that perhaps it had the word tree in its name, or the word map, or something like this. So I can type 3 or any regular expression to be precise, and I get a list of all the functions that match this regular expression, which are currently loaded. The key, this is key to the functionality of many things in CIDR, as the functionality is provided by the REPL process. You are going to get results only for parts of your application that are actually loaded in the REPL. If something is in the source but it is not loaded, it is not going to appear in the results. Important thing to keep in mind. So we've got just one match. From here we can also quickly go to the documentation if we press return, or to the source, or wherever you want to go. If we try the apropos functionality, I'm going to invoke the command in a different manner. Using the mini buffer completion is an interesting way to explore. You just type CIDR dash and you're going to see all the available commands. So let's check for map. Now there are a lot more matches. So useful stuff. But there are other ways to be doing documentation searches. Maybe you just remember that some function or some macro had the word tree or map in its docstring, not in its name. So for this, we've got a different apropos. If you're curious, how am I seeing those key map hints in the bottom? This is a special minor mode for Emacs, which is called which key. It is extremely handy if you're working with a mode like CIDR that has a ton of key bindings. Without which key, even I don't remember the key bindings. As I told you, we've got so much functionality that from time to time, even I forget it. For instance, while I was prepared for this presentation, I couldn't remember what the E key binding was for until I pressed it, and now I'm going to press it. So let's search for map. And what this does is it searches for all loaded symbols that have map in their docstring. It returns a list of them that you can go through in the mini buffer. So I can select one method, one function, sorry about this, like array map. And then I'm prompted for an action to take on this symbol, whether I want to display its documentation, find its definition, or look it up in the online Grimoire documentation repository. So I want to find the definition. Yay, very handy. And as usual, I can go back to the source code afterwards. So there are many documentation commands. So let me check the documentation section. Something interesting is that you can look up stuff on Grimoire, which is a great service, either directly in Emacs or in your browser. And you can also check JavaDoc directly from Emacs, which many people find very surprising. So let me show you this. Not toString, something. So if I wanted to uppercase my name, this works. Although nobody should write code like this. More importantly, there is an LDoc for the Java method. And there is something peculiar to notice. You see in the beginning that there are two potential classes that implement the toUpperCase method. One is JavaLang string, the other is JavaLang character. We cannot possibly know which one you are trying to evaluate here. Sorry about this. So we just tell you those are the possibilities, and we display the signatures of all the methods. It's not ideal, but it simply cannot be done in any other way. Still, I believe it gives you a lot of context. And if we try the standard documentation command for to uppercase, it is going to prompt us whether we want to see the documentation of the to uppercase method in character or in string. We select string, and we get the documentation with some rather decent formatting directly in an Emacs buffer. I think that this is super handy, and what's more, functionality like going to the source code works for the Java things as well. It doesn't work just for Clojure. So Cider really tries to solve the problem of working on an application with a mixed code base of Java and Clojure. Traditionally, the Java support in Emacs hasn't been very good, but slowly we are making some steps to address this. Okay, so this is good, and we also have support for JavaDoc. It's similar. JavaDoc is always displayed in the browser if you fancy this stuff. We also, I didn't show you the integration with Grimoire, so let me show you this. Control-C, Control-D, and let me be reminded what is the magic key I'm supposed to press. The magic key is R. So Grimoire for string. We are doing one HTTP request, and we retrieve the documentation from Grimoire. The documentation in Grimoire includes extra things like user submitted examples about the usage of some functions. So this is much richer than the standard documentation, and this is why we elected to add special support for Grimoire to our code base. Okay, so fancy documentation lookup stuff, but not super impressive, right? Let's see what else I can show you. Debugging functionality. There are many tools in Cider to help you debug something. The first that I'm going to show you is our tracing functionality. So here I've got one super inefficient recursive implementation of factorial. Let's evaluate it once to make sure it works. This is a little bit surprising. Unable to, oh yeah, I'm in the wrong namespace. Let me show you some basic Cider magic. You can obviously come here, type the namespace that you want to switch to. There is also a repo command to do this, set repo namespace, but we don't want to do it because we are going to be Clojure pros. We are going to do Control-U, Control-C, Control-Z, and this switches to the repo, and at the same time it changes the namespace of the repo to the namespace of the current Clojure buffer. This is super convenient when you're working with many Clojure buffers and you want to be in the proper namespace in the repo every time. So now we are in the proper namespace, and I get completion. Yay. Who remembers factorial of 10? Does this sound like the right result to you? I believe that from 3 it was 6. 1 by 2 by 3, yeah. So it seems to be correct. But how to validate this, especially for bigger numbers? How can we see that all the steps are the steps that we wanted them to be? We've got this functionality called tracing, which is invoked with Control-C, method T, and V. Yeah, I know that the bindings can be a little bit overwhelming. So you have to select the name of the var you want to trace. In our case, factrec. You see that the name of the function was changed. It is now in a little blue box. Depending on your core team, the change in the name might be something else. But if we evaluate this now, we get totally different output. Not only did we get the result, but we also see all the nested recursive invocations. So we see that factorial Reka 5 invoked this, which invoked this, which invoked this, which invoked this. It finally returned some result, which was propagated, 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 and we see all the intermediate computations that were done by our recursive definition. And this is standard recursion, so it doesn't look very fancy, but if we do this for Fibonacci, where we have a tree recursive process, it is going to look even more impressive. I don't even know why I got here. Okay, so now you see how the different branches of Fibonacci get executed. This is pretty crazy. It gives you an immediate overview how inefficient the standard recursive implementation of Fibonacci is. And if we compare this with a recursive tail recursive implementation, which is basically an iterative process similar to running a loop in a let's call it traditional language. So I've got one of those here. This is its definition. So we're going back to the repo. Sorry.
I have a question. So
Yeah.
is there a way to write trace to data structure so I can visualize it?
Not right now, but potentially this should be easy to do. Right now we are calling into a higher level method that directly outputs the string representation of the call sides. If we use some lower level methods, we should be able to dump it in any data structure. There are really no limitations here. This is a potential improvement point that you can work on. I'm always trying to solicit contributions. So let's see what happens with the tail recursive version. I used Fibo Reka 5, right? So let's do the same. This is it. Just two call sites. And the second is just because you have to pass some argument to the first. If you go to the implementation, you're going to understand me. This function has two signatures, and basically you use one to pass some default values to the other. So this is a much more efficient process, and by using this tracing functionality, you quickly verify these statements. So we can disable tracing here. Oh yeah, and some basic Emacs tips. So you can go to Emacs like this. This is horrible. Pro Emacs users use something called AV, and it allows you to. AV is the successor of HJump. If you're using HJump, you should stop using it and switch to AV. Okay. So the same command that enables tracing for one function also disables the tracing, and there is one more command that is similar. Let me just find it. So there is a command to toggle the tracing for every function in a namespace. So if you're feeling adventurous and you want to get super deep insight about the invocation of all your functions in a namespace, you can just use it. So what else do we have in our debugging arsenal? Something that is super basic but still kind of handy is our inspector. So the inspector basically allows you to second. Oh, this inspected the thingy at point. I need something better. sorry about this. Expect expression. Yeah. So here I passed some expression to the CIDR inspect expression command, and the command gets evaluated on the result, executed on the result of this expression. The result is a seek with 10 elements. You see here the contents of this seek. You can drill down. For instance, the first element is some number. You can press return on it. You see that it's an instance of Java long. You see its value. You see some static fields that are defined for it. This is really powerful. It's actually more useful for maps than for linear structures. But it is a very useful tool when you want to dive deeper and deeper and deeper into a deeply nested structure. Otherwise, you might get crazy. So this is the inspector for you. And by default, the inspector actually works on whatever is at point. So if I press inspect here, we'll choose by default Control-C, Control-E maybe. Oh, tell me it was this. No, it's not this. This is embarrassing. What was it? Control-C Meta-E. It inspected, not the result. Okay, honestly, I don't use the inspector that much. So I have to check the documentation to see which command was doing which. But before it was hard, and now we have the manual. And I believe that in the debugging section, there are some useful tips, which you can read later. I just wanted to give you an idea that there are better explanations here than the ones that I'm probably supplying now, because I myself don't use the entire functionality, and the inspector is one of the features that we ported from Slime, but I've rarely found a good use case for. On the other hand, I really often use our interactive debugger, which is enabled with Control-U, Control-Meta-X, or Control-U, Control-C, Control-C. So once a function has been instrumented for debugging, evaluating it is going to introduce some changes. The debugger stops at the first non-special form, and by pressing N, you can go over the forms, see all the intermediate results. So N becomes 4. This is still false. I don't know. I hope you understand what is happening. It is exactly like stepping through the debugger in an IDE. We've got some extra magic here. For instance, you can evaluate expressions in the context of the current code. So N was what? I don't remember. Let's check it. So N is 2. I can do any expressions involving N. And this is another super cool feature. Do you see where the LDoc appeared while I'm in the mini buffer? It appeared on top. So even in the mini buffer expressions, you get to see information about the signature of something. So you can write something like this is some parodied bug. You can write this, and yay, you get the right result. So this is handy. You can quit the debugger with Q. You can see the stack trace at this point with S, which is useful. You can see all the stack frames here. This is actually the very same stack trace buffer that you are going to see in case of errors. And like usual, you can filter out certain types of frames. For instance, you don't care about implementation details in Java. You press this toggle button and all the Java frames disappear. You don't care about the REPL frames. Bam, those disappear as well. This is really handy. You want to see some tooling frames like code invoked by the debugger itself. You enable the tooling frames. Magic. Typically, it's best to use just a combination of the Clojure and Java frames, and feel optimistic that we did the filtering of the other frames properly. Okay, so what else is useful here? Oh, I really like the ability to display the local set point here. We have just one. It is n and it is 2, but in a more complex function, in a more complex surroundings, you would see something different at this point. So let us continue. Yay. So this is the debugger for you. The important thing to keep in mind is that a function is going to remain instrumented until you reevaluate its definition. So when you're done debugging it, when you are certain that it behaves the way you want it to behave, you should reevaluate it. And at this point, this is not going to trigger the debugger. Some people get really confused by this. The debugger is one of the pieces of functionality that is described in great detail in the manual. So this is definitely the definitive resource on debugging. There are also some implementation details that we have listed here for people who are curious about how the debugger works and want to add additional features on top of it. The implementation is pretty straightforward. If you have any Clojure experience, I guess that it should be relatively easy for you to figure out how to use it. So, what else do I have for you? Let me get some inspiration. Oh yeah, this is cool. We've got something that we call the namespace browser. So if you want to see all the symbols defined, all the vars defined in one namespace, this is the command you need. This implements some important commands for every symbol. With D, you can quickly see the documentation. With S, you can quickly go to the source. It is really handy if you just want to skim through some namespace. If some of those vars had any documentation, it would be displayed here. Let me show you this. Where are you? Demo. This is not right. So, and this is the good thing about this gets me every time. Obviously, this is the proper position of a docstring in Clojure. So if we refresh this, what was the refresh command? If we refresh this, the test doc appeared here. Okay, more functionality in Lighten, another great tool to do debugging. So here we've got this function foo, which does some useless stuff, and we've got this function bar that calls the function foo. We invoke it and we get nil. Not very useful, but what happened in the meantime? Well, we enable Cider in Lighten mode. Almost. We enable it. We have to reevaluate the buffer. And when you, we had to reevaluate the definitions. Yeah. So now we are enlightened. And now that I do the evaluation, you see that all the intermediate values appear right next to the symbol names. So you see what were the substitutions that happened in full. You see the intermediate result. And this is another great way to debug. I believe that very few people are aware of the Enlighten functionality. It's a little bit confusing that once you disable Enlighten, you still have to evaluate again the related functions. Otherwise, Enlighten is going to continue working with them, because when Enlighten is enabled, it adds some metadata to the functions that the middleware always interprets. Maybe we can do it better, but it is what it is, and it kind of works. So these are some basic debugging techniques that you can apply, but there are more interesting things that I'd like us to discuss. For instance, working with tests. Sorry. So in our small project, we've got a couple of tests, one basic test, one not so basic test, but which is still pretty basic. What can we do with the tests? We can run them, I guess. Let's run the namespace tests. So there are 3 assertions which were executed in 2 test functions. And we have 2 failures, 0 errors. Can Cider help us figure out where the errors are? Sure it can. As you can see, the failing assertions have been highlighted in red by Cider, here and here. Obviously, 2 is not equal to 1. So let's evaluate this and rerun the test. Oh, sorry, I showed you accidentally a different command. This is the command that runs the tested point, Control-C, Control-T. While I actually wanted to run Control-C, Control-T, N. Okay, this is surprising, because yeah, 1 failure. Okay, it's correct. It's just surprising to me. I'm so surprised every time something actually works. So why is this failing? It's failing because we changed the code here in the other core, of course. And if I had any brains left at this time of the day, I would actually do the following. Much more efficient, right? So sorry about this. We have to change this to Bojidar, as he's the one true master. And we can rerun the test now. Notice that you don't have to actually be in the test buffer. You can do it from here. CIDR is going to automatically infer the namespace of the tests and run them. So this is pretty handy. Unfortunately, we have support only for tests written without time. Okay. Unfortunately, out of the box, CIDR supports only Clojure test, the test framework that comes with Clojure itself. But Clojure test is more than just a framework. It's a set of protocols that any test framework can implement, and CIDR is going to work with this. This is why CIDR also works with TestCheck, because TestCheck implements the necessary machinery. I know that there has been interest in implementing this machinery for Mitch and for SpecCLG, and I really hope that this is going to happen at some point in time. Otherwise, it is really hard for us to maintain the different frameworks. This adds a lot of complexity. I much rather prefer several frameworks that are implementing some common machinery. So for the tests, there are other things that you can do, other interesting functionality. Let's go here. Let's break some stuff again. So we change this. We run this test. Sorry, I don't know what's happening to me. So the test is failing, but notice that there is some extra information here. You actually see the failed assertion, the expected assertion, and from this buffer, you can actually quickly go directly to the problematic definition, something that it's probably not very obvious from the amazing user interface that we have developed. Okay, and now it works. There are actually fancier reporting capabilities that are not enabled by default, and probably this is how I should conclude the presentation. The worst kept secret in the universe regarding CIDR. No, I shouldn't conclude it like this. I should show you the macro expand functionality, of course. So let me just remember what were the key bindings for macro expansion. It was here somewhere. Okay, yeah. So there are two macro expansion commands. One is macro expand 1, which is going to do just one step of macro expansion. Let me show you this. What the fuck? Yeah. Now I remembered. It works when your cursor is at the end of the form. So going back, there is really a lot of room for improvement. I can't deny this. So you see how this got expanded. If it was a more, in this particular case, this macro expansion is probably going to be the same as the complete macro expansion. Not exactly the same. It seems that FN is also a macro. I felt that it was a special form, but it's not the case. So if I go back to the previous example, here you can continue expanding more and more. So one step of macro expansion, and if you press the same combination again, a second step, which is, let me see what the key binding for this was. Yeah. Yay. As you can see, I don't know how to use my own project, which should make you really skeptical. But honestly, too much things to do, and lately CIDR hasn't been one of my primary focuses. So the macro expansion functionality is is really priceless if you're writing macros and they don't behave the way you want them to behave, which is pretty much always the case. You know the first rule of macro co-op, don't write macros. You probably don't need them. So now is the time for the top secret, top tip to success with Cider. Customize group, Cider. This is the way to see all of the things you can customize with Cider. As you can see, the scroll is really up. There is so much configuration options. It is epic. It is beyond epic. I'm really afraid what we have done. I go through the names of some of those options and I have no idea what they are. But those are things that you can configure. There are several subgroups for major functionality like debugging, documentation, the inspector, the repo, the stack trace buffers, the testing functionality. So you can obviously use the same command, customize group directly for Cider test, and you're going to get some saner output because there is less configuration for tests. There is a lot to Cider. There is a lot that we didn't touch upon at all. So customize group Cider is your friend. The manual is your friend. The changelog is your friend because often I forget about some new functionality 10 minutes after we add it. When I'm doing some conference talks, I'm really surprised. Oh, we had this functionality. That's new. So yeah, with great complexity comes great complexity, and with great complexity comes great perplexion. Malcolm, what is the word you use in English when somebody is super confused? Perplexed? Yes. So there are also some cool animations in the manual. I was wondering where I had seen those. So a lot of cool things. I didn't mention this at all, but with Cider, you can be connected to several Clojure projects in the same time, and Cider is intelligently going to route the evaluation commands over the proper connection to the proper repo. You can have a Clojure script repo and a Clojure repo running side by side. There is a command to start a Clojure script repo, Cider Jekyll Clojure script. We support more than Leiningen. We support Boot. We support this old Java thingy, Maven. We support the newer Java thingy from the Groovy world, Gradle, but nobody uses those. And there are some really cool things that you can play with. For instance, you can instruct Cider how to indent your code by using special metadata. This is an indentation specification that I don't have the time to go into details with, but if you don't like how Cider indents something by default, you just add style indent and the type of indentation you want, and Cider is going to abide by your rules. This is pretty handy. Cider does a lot of metadata inspection. We are also using this to cover differently some things in the repo and in the source buffers. Let me just show you something before we conclude. Wrong core again. What? Okay, I'm really confused. What did I do? Yeah. Not my best demo. So, notice how everything here is kind of ugly, right? But if we do one magical incantation, set Q, Cider, dynamic Font lock dynamically. And perhaps if we reevaluate this buffer. Okay, this is not how it was supposed to behave. Forget what I told you. But the dynamic font locking functionality basically should be highlighting differently symbols that are known to CIDR, like function names, macros, and so on. This used to work. So I guess we recently broke it, and I'll have to investigate what happened there. And another embarrassing moment. So we're out of time, and you are overwhelmed and perplexed, perhaps. So let's leave it at this. It was really a pleasure for me to be here and to be able to do this extended presentation for you. Thanks. Okay. So